Here are a couple exponential equations that are actually pretty simple to do as long as you know this pretty easy trick to use. And what that trick is going to be to write each side of the equation so they have the same base. So for example, as I look at this first problem, I have one side that has a base of 8 and one side that has a base of 64. Well, hopefully I recognize right away that 64 is really just 8 to the second power. And so what I'll do is I'll rewrite 64 in that format. Now notice I didn't change the problem, I didn't take a square root, I didn't do anything. I just replaced 64 with 8 squared, which is the same thing. That 64 had an exponent of 3n on it, so this 8 squared still has an exponent of 3n on it. On the other side, since that already has a base of 8, I'll keep it the same. And as we looked at in the last couple examples in the last video, we said, was if you have the same base, you can go ahead and ignore them. Actually, I'm jumping ahead of myself. One thing I want to do before I get rid of my base, let's get these exponents combined right here. So since I have a power raised to a power, let's go ahead and multiply those exponents together. That's what our exponent rules have always been. So I can rewrite that as 8 to the 6n is equal to 8 to the 2n minus 3. And so as I was saying a minute ago, now that I have the same base on both sides, just like we've done before, let's go ahead and just ignore that base. I already know the base is the same. And let's just worry about making our exponents equal to each other. So I'll rewrite my equation as 6 equals 2n minus 3. And then solve that. Hopefully no issues solving this. I'll add 3 to both sides. And then divide both sides by 2. And I end up with a final answer of 9/2 or 4.5. So there's one of them. Again, pretty simple trick to use, no logarithms, nothing fancy required. Take a look over here at this next example. It's almost as easy with one, I guess, additional trick to it. So I'm noticing that I have a base of 4 and a base of 32. Well, if I try to run through some powers of 4 in my head, 4 squared, 4 to the third, I can see that none of them are going to come up to be 32. And so this time it's not going to be as simple as just changing one side, but I could change both sides of my equation to have the same base. So for example, I know what's going to happen, but maybe I just have to get lucky or know how my numbers are going to work out. But I recognize that 4 is going to be the same thing as 2 to the second power. So I'll replace 4 with 2 squared again. I didn't change anything. I didn't take a square root. It's just changing what 4 looks like. And then I'm trying to think, can I write 32 as 2 to some power? Maybe I need to reach for a calculator to double check it, but it turns out that, yep, I can. 32 is just 2 to the 5th power. So there should be a trick like that that you can use. And again, if the numbers don't jump out at you right away for what base to use, get a calculator. There should be something you could do to make it work out. Once again, let's go ahead and multiply our exponents together. So this becomes 2 to the 6x over here. I have a power to a power, so I'll multiply. I'll do the same thing over here, keeping in mind to distribute that. It's really 5 times x minus 1. And when I do that, that side becomes 2 to the 5x minus 5. And once again, now that I have the same base on either side, now I can go ahead and just ignore the bases and cross those out and just worry about making my exponents equal. So I have 6x equals 5x minus 5. I want to get my x's to the same side, so if I subtract 5x from either side, I end up with a well, actually I'm done at that point because 6x minus 5x is just x, is equal to -5. And so there's my missing x value.